Right, good morning, class. Now we are again back with the numericals. Yesterday we have solved up to question number 8, and I've given you one homework, isn't it? So, the numbers which we are skipping, the one which I'm not solving here, you may try at your own. Okay, those are simple sums. So, those sums which are simple, I've left it out. So, today we'll begin with question number 10. Today's session will be winding up session for chapter current electricity. We are doing unit C, electrical energy and power, and the numericals based on electrical energy and power. So from the remaining numericals, today we'll be doing 5 numericals which are different in each other, different with each other. So the remaining numbers which I have not done or I'll not do today, you have to do it by yourself, try yourself, and you can send me the solution. Okay, or you can ask me any help if you require when you are doing those sums. So you have to watch the video properly, because in between I give you assignments. So to note down the assignments as well as to understand and learn to solve the numericals, you have to watch the videos properly. So in between you can pause and re-watch the video if you get confused, or you let me know. Okay, and after you finish watching the clip, please drop your name in the YouTube, comment your name, so that I will know how many of you have watched the video. Okay, so let's begin with question number 10. So if you see question number 10, it says a current of 0.2 ampere, okay, flows through a wire whose ends are at potential difference of 15 volt. Calculate the resistance of the wire and the heat energy produced in 1 minute. So one more information is given here at the end, that is 1 minute, that is time. So first of all, let us jot down the rule number 1 under the heading given. 0.2 ampere, so that is one physical quantity given. Another one is 15 volt, so 15 volt, and here you have 1 minute. So now ampere is the unit of current, so you'll write given I is equals to 0.2 ampere, because I is the letter that we use to represent current. This is voltage, potential difference means V, understand, that is potential difference. Then you have 1 minute, that is the time. So 1 minute means 3600 second, right? Am I correct? No, I'm not correct here. 1 hour is 3600 second, but here you have 1 minute. So 1 minute means 60 second. All right, so now what are we supposed to do? We are supposed to find the resistance, understand? So we know, the Ohm's law, V equals to I R, or from here R equals to, if you make R as the subject, you will get R equals to V by I, isn't it? So how much is V? V is given 15. How much is the current? 0.2 ampere. So when you remove the decimal, you will have 15 into 10 divided by 2. So 2 1 time and 2 5 time is 10. So 15 into 10, 15 into 5 is 75 ohms. So you get the solution for number 1, the resistance of the wire. So here don't forget to write the statement. Okay, the resistance of the wire is 75 ohm. Is that okay? Now question number 2, what you have to find? You have to find heat produced. Okay, so heat energy is given by W. So heat energy, W equals to, the relation, I square R multiplied by T. So I is 0.2. So 0.2 square into resistance. R is resistance, the one that you have calculated in number 1. So multiplied by 75 into the time mentioned here is 60 seconds. So when you multiply this, you are going to get 0.2 square is 0.04, okay, into 75 into 6. So 6 into 75 is 450, and you have one more 0 from 60 here, so you will get 4500. all right, so when you multiply with 4 into 45, 4 into 45 is 180, okay, and you have 2 zeros here, so I'll add 2 zeros here, but there are 2 place decimal here, so count from the back, 1 2, so my decimal will be here, so I'll get 180.00, so that means 180 joule. So here write the statement, therefore the energy, okay, produced in 1 minute is 180 joule. Is that okay? It's very simple numerical. Question number 10. I hope everyone has understood. If you are not able to get it, again, okay, drag back the video and watch the video again to understand this very, very simple numerical. So I have started with a very, very basic and a simple numerical today. Okay, so slowly we'll be progressing with the harder one. All right. Okay, now let's move to next question. Let's see which question I have put here. So I have put here question number 12. So this is our question number 12. Okay, so question number 12 says 2 bulbs are rated 60 watt, okay, 60 watt under 220 volt, and another again 60 watt bulb, okay, but the potential difference applied here is 110 volt respectively. Calculate the ratio of their resistance. So we need to calculate the resistance of these 2 bulbs and then compare, okay, because ratio means comparison of the 2 resistances here, and whenever we are comparing or we are finding the ratio, they will never carry or possess any units. So that is why you can see the answer here. Answer is 4:1. There are no units because it's a comparison. Okay, ratio means comparison of same physical quantities. All right, so let's jot it down with the given 60 watt is P1. Let me, because there are 2 bulbs, so I'm writing P1 for the first bulb, okay, and V1 is the potential difference applied here for the bulb B, first bulb. For the second bulb, I'll write P2, and the power of the P2, power of the second bulb, that is P2, is again same, that is equal 60 watt, and it is has a rating, voltage rating of 110. So I'm writing V2 as the voltage rating. Okay, so you know, okay, we have to apply best relation, best formula, rule number 2. So you know P is equals to V square by R. So there are 4 formulas to find power, but this is the formula where the 2 information provided by the question is relatable. So I'm writing P is equals to V square by R, or R is equals to V square by P. Is that okay? So with this concept, I can find the resistance of the first bulb. So I'll write R1 equals to V1 square by P1. Are you getting my point? Yes. And R2 is V2 square by P2. Is that okay? Are you getting here? It's very simple, isn't it? Or R1 equals to V1 is 220, okay, into 220. Why? I'm multiplying 2 times because there is a square here. So V1 is square. When you say V1 let do multiply, right? So 220 into 220 divided by 60. And here I get R2. R2 equals to the potential difference for the second bulb is 110. So that is the rating of the voltage for the second bulb. So 110 into 110 again. Why? Because there is a square. So I have to multiply it twice, divided by 60. Alright. So now what do I need to do? I need to find the ratio as per the question. So by question I'll write, okay, since I have to find ratio, so I'll be dividing R1 with R2. So that will give me now 220 into 220 by 60. Everything gets divided by 110 into 110 divided by 60. So 60 and 60 from the numerator and the denominators they get cancelled. 1 0 and here 0. 11 1s 11. 11 2s are 22. 1 0 here and 1 0 here gets cancelled. 11 1s are 11 2s are. So I am now left with 4 divided by 1. So therefore I get the ratio 1 R1 is to R2 equals to 4 is to 1. So do not forget to write this statement again here. So this is how I do question number 2. So the ratios, okay, of the resistance, or you can write the ratio of the resistance of two bulbs is 4 is to 1. Alright, so this is how we solve question number 12. Alright, now let's move to the next question. So here you can see the next question that I have kept here is question number 13. So we are now solving question number 13. Alright, so see, it's not necessary that you have to watch the video continuously. You can in between, you can pause the video, you try to understand how I have solved, and then again, as I said to you yesterday or in the earlier videos, okay, you always have to copy the numericals. Watch the numericals. Do not copy directly from the video. Watch the numerical, then do it by yourself. Then in between, when you get stuck, then you again go back to the video and get the hints. Okay, just don't make a habit of copying and showing me the work. Alright, so now question number 13. Let's see what does question number 13 say. Okay, it says an electric bulb is rated. So there is a rating 250 watts. So this is the power rating, and through 230 volt, this is the voltage rating. Okay, so calculate the energy consumed in 1 hour. So another information is given here. 1 ghanta. 1 hour means 1 ghanta. Okay, and the time in which bulb will consume 1 kilowatt hour energy. Okay, when you are connected this to 230 volts. So you are asked to find the energy consumed in 1 hour. Then you are asked to find कति घण्टामा चाहिँ 1 kilowatt energy consume गर्छ यो bulbले. That is what the question says. Are you getting my point? So don't get confused. Time is already given, but in the second question again time खोज भन्दैछ. Don't get confused here. First question मा चाहिँ energy 1 घण्टामा यो bulbले how much it's going to consume. Second मा चाहिँ यही same bulbले 1 kilowatt energy चाहिँ कति घण्टामा consume गर्छ. So that is the question. You need to understand the question. All right. So let's begin. So you know that I have to write the given information. P is equals to 250 watt. V is equals to 230 watt. This is what the question is giving me. All right. Then I have time. Time is 1 hour. Now 1 hour, 1 ghanta means how many seconds? 3600 seconds. So I got the time as well. All right. So let's solve question number 1. So energy, you know the relation. Energy is P into T. W is equals to P into T. You can write here W as well. So power is 250. Time is 3600. That is 3600. Okay. That when you multiply this, you'll get 25 into 36 is going to give you 900. And you have 1, 2, 3 zeros. So you'll have like this. Okay. 90,000 joule. So this is your solution. Okay. You can leave as it is, or it is always to be in a safe side by writing the answer in the exponential form in physics. So 90,000 you can write it as 9. Okay, so we have 3 zeros. Sorry, it's not 90,000, it's 90 lakh. Okay, so 1, 2, 3 zeros are there. So 3 zeros, 25 into 36 is 900. So you'll have 9 into 10 to the power 5 joule, and here you write the statement. So this is the energy consumed. Now second part of the question is there. Second part of the question, let's say what we are asked to find. We are asked to find time. Time for the bulb to consume 1 kilowatt of energy. Okay, so 1 kilowatt energy चाहिँ कति घण्टामा चाहिँ यो bulbले consume गर्छ. This is our question. All right. So we know the formula that energy is given by P into T. So you are going to use the same relation, ये relation use गर्छौं. But here energy is already mentioned in the question, that is 1 kilowatt energy equals to power is 250, okay, into T. Time खोज्नु पर्यो. Okay. Or you know 1 kilowatt hour भनेको चाहिँ it's how much? 1000 watt hour equals to, okay, 250 watt into T. Are you getting my point? Or make T as a subject, so you'll get T is equals to 1000 watt hour divided by 250 watt. Watt or watt cancel, 0 0 gets cancelled, 25 ones are 25, 25 fours are 100, so you get 4 hour. So 4 hours, 4 घण्टामा चाहिँ this bulb is going to consume 1 kilowatt of energy when it is connected to 230 volt mains. Are you getting my point? So this is very, very simple, easy. If you get confused, ask me. Alright? Is that okay? Now, today's assignment. Today's assignment is, you will solve question number, let me see, question number 9. Question number 9 is your today's assignment, first assignment. Alright? Okay. Now, question number 13 is over. 3 questions are over. In the beginning of the video, I said I'll be doing how many videos? How many numericals today? 5. So we have 2 more to go. So after 13, now we go to the next question, that is question number 17. Alright? So we are now going to do question number 17. So before you go to 17, please make sure that you thoroughly understand question number 13. Alright? So when you understand question number 13, 14, 15 and 16, they are somewhat similar to question number 13. So that is why I'm not going to do it. Okay? Now let's do question number 17. Okay, question number 17. Let's read the question. A battery of EMF, one information here, 15 volt and internal resistance 2 ohm. So we have internal resistance here. Okay, sorry for the interruption here. Okay, so here we are in question number 17. Okay, let me read the question again. A battery of EMF, okay, so there is a battery of EMF 15 volt, one information, and internal resistance 2 ohm, second information, is connected to 2 resistors. See there, how many resistors are there here? 2 resistors. One is 4 ohm resistor, other one is 6 ohm resistor. They are joined in series. Another condition. Okay, find the what electrical energy spent per minute in 6 ohm. Are you getting my point? Where? In 6 ohm resistors. So many information is given there, but at the end 6 ohm ma मात्रै कति चाहिँ energy spent हुँदैछ त्यो सोध्दैछ. So to find the energy spent, you must know the thing, current. First of all, you must know the current. So let us first write the rule number. Let's follow the rule number 1. Given 15 volt is EMF. So EMF is equals to 15 volt with internal resistance. Small letter R is the internal resistance. Okay, small letter R is the letter that is used to represent internal resistance. 2 resistors are there, so I'm going to name it as R1 and R2. So R1 is 4 ohm and R2 is 6 ohm. They are joined in series, so all of them are joined in series. So I can find the total resistance here. Total resistance, that is R equals to R plus R1 plus R2. So that is 2 plus 4 plus 6. That is going to give me 12 ohm resistance. Alright. So with the help of this, I can get the current. So from here, from the Ohm's law, I can get I is equals to V by R. Now you know, since V is equals to IR, this is from Ohm's law. So here the potential difference or the EMF here is how much? 15 divided by total resistance is 12. So 3 4s are 12, 3 5s is 15. So 5 by 4 means 4 1s are 4.42s are 8, and 4 remainder is 2, so that makes 20. 4 5s is 20. So I'll get 1.25 ampere. So this is the current. Are you getting my point? Yes. Now you know the formula to find the voltage. अब 6 ohm मा जाउँ. अब चाहिँ 6 ohm मा चाहिँ, okay, I have a 6 ohm resistor here. Now I know 1.25 ampere of current is flowing through this 6 ohm, but what is the potential difference across its end? That I don't know. Alright, so first of all, let me find the voltage. So now voltage across R2. Okay, voltage across R2. Okay, so let me represent it by V2. So that is going to give me, by the relation, V is equals to IR. So here I'll have V equals to I into R2. So that is 1.25 is the current, that is the one that we calculated just now, into R2 is 6 ohm. So this is going to give me, when I multiply, it's going to give me 7.5 volt. Alright, now the question said us in 1 minute, 1 minute मा चाहिँ कति एनर्जी चाहिँ यहाँ स्पेन्ड हुँदैछ 6 ohm resistor मा, right? So T is given 1 minute. 1 minute means 60 seconds. Alright, so now we'll write energy across R2, that is E, equals to V2 square multiplied by T into R2. So here the voltage was 7.25. So 7.25 whole square into time is 60 divided by how much? 6. Because the resistance here across R2, that is 6 ohm ma khoddechhau हामीले, isn't it? So 6 1s are 6, 6 10s are 60. 75 into 75 is going to give you 5625. So now when you square here, you will get 2 place decimal, so you'll have 56.25 into 10. So when you multiply with 10, the decimal is going to move 1 place to the right. So that is going to give me 562.5 joule. Okay, so this is the energy that is going to be spent, okay, in 1 minute or per minute in 6 ohm resistor. So you have to write statement at the end, rule number 4. Okay, so this question was a bit lengthy. Question number 17. Similarly, the next question, question number 18, is also somewhat similar. So we are not going to do that. We will do question number 19 now. All right. Okay, excuse me. Now, question number 19. If you see question number 19, it says an electric toaster draws current 8 ampere in a circuit with source of 220 volt. It is used for 2 hours. See, I am circling the information is given in the question. Find the cost per of operating the toaster if the cost of electrical energy is rupees 4.5 okay, पैसे 50 पैसे per kilowatt hour. 1 kilowatt hour को चाहिँ 4 रुपैयाँ 8 आना हो भने चाहिँ, okay, how many rupees you have to pay, okay, when you are using this electric toaster for 2 hours. यो electric toaster चाहिँ 2 घण्टा use गर्यो भने चाहिँ how much you have to pay, and what is the rate? Rate is rupees 4.50 पैसे per 1 kilowatt hour. 1 kilowatt hour को चाहिँ 4 रुपैयाँ 8 आना हो भने चाहिँ यो electric toaster which is drawing a current of 8 ampere under the voltage of across the voltage of 220 volt when used for 2 hours, how much you have to pay. So this is the question. All right. So now first of all, let us jot down the given information. Given first my 8 ampere is given, so ampere is the unit of current, so I is equals to 8 ampere, 220 volt, so that is voltage, okay, and 2 hour, that is time. So now here we'll not convert the time. All right, why? Because we have to find the cost, and cost means commercial purpose with the right. So commercial unit is kilowatt hour, hour mai cha, so time pani hour mai cha, so we'll leave it as it is. We'll not convert that into second. All right, so we'll write, we know electrical energy, here you write electrical energy is equals to V I into T. So V is 220, I is 8 into 2, so that is going to give you 22 into 2 is 44, 44 into 8, 8 4s are 32, and 8 4 the 32, 32 plus 3 35, so 35210 is here, so it will give you 3520, okay, watt hour, watt hour. So now watt hour like, how do we convert? We convert by dividing by 1000, we'll get kilowatt hour. So this 00 gets cancelled, so I'll have 3.52 kilowatt hour. Are you getting my point? So this many kilowatt energy will be, okay, spent by this electric toaster when it is used for 2 hours. Now कति पैसा तिर्नु पर्यो? So here it says 1 kilowatt लाई चाहिँ you have to pay rupees 4.50, means 3.52 लाई चाहिँ कति use गर्नु, कति pay गर्नु पर्यो? So it's, you have to just multiply, isn't it? Yes. So here I'm going to do, since cost of energy, let me use other color, energy is, okay, rupees 4.50 per kilowatt hour. So therefore cost of 3.52 kilowatt hour will be rupees 4.50 into 3.52, that is going to give me this much. Okay, so rupees 15.84. all right, so this is how we will do. All right, so after completing this question number 19, you will do question number 20 as your second assignment for the day. And these two questions, okay, which I've given you, question number 9 and question number 20. Okay, question number 9 and 20 is your assignment for the day. You will do it and you will send me in between 5 to 6. Remember, today I'm going to accept only from or between 5 to 6. You will not send me earlier before 5 p.m. Okay, you will not send me after 6 p.m. 5 बजेदेखि 1 घण्टाको फ्रेममा चाहिँ you have to send me these two questions as your solution. All right. Okay, that's all for today. Thank you.